Now, our last discussion revolved around classes and objects and how they are presented by attributes and methods. Now, we will talk about how these classes are related to each other. Now, let's begin by taking an example from real life. How is a car related to its wheels? You'd say that the wheels are part of a car since a car without wheels would defeat the purpose of a car being a car in the first place, right? How about this? How is a page related to a book? You could say that the book is entirely made of pages. If you think about it, how will a book serve its purpose without pages, right? Guess that means you could finally read a book by its cover. Oh wait, you could consider the cover as a page too, so there's that issue. Finally, how is a customer related to an order? You could say that the customer sometimes makes an order. The thing is, without an order, the customer would still exist. However, the order is always dependent on the customer. Now, these examples make up the first class relationship that we will discuss here in our object-oriented programming series. We call this first type of relationship association. There are three types of association. The first example, the car and its wheels, represent the first type of association called aggregation, wherein a class is merely a part of another class. The second example, the pages and the book, is what we call composition, wherein a class completely makes up another class. It is a stronger version of aggregation where the parts live and die with the whole. The third example about the customer and the order is what we call dependency, wherein a class is dependent on another class. Usually, dependencies are just implementation details and are not necessarily an intrinsic part of an object state. Alright, let's have another example. Given the following classes, movie theater, box office, and movie, how are these three classes related? Well, first, let's talk about the relationship between the movie and the theater. If the movie suddenly vanishes, will the movie theater still exist? That eliminates the second option, composition, since, the movie theater would still definitely exist if the movie vanishes. Now we're left with two. Do movie theaters also show movies? Well, definitely. Therefore, we can say that the movie is an essential part of the movie theater, making this one an aggregation. How about the entire box office at the movie theater? As you may know, the box office is made up entirely of movie theater income. Therefore, this is a composition. Because without movie theaters to show movies and collect tickets, there would be no box office at all. Alright, test yourself. Check out the supplementary sheet containing how to represent these relationships in a UML class diagram and answer the exercise given.